Good morning, everyone. How's everyone doing today? Can I get some soon thumbs up? Oh, sorry, I'm not in. Okay, awesome. Well, we're so happy to have you back for another week of EqualScore tutoring. Last week I wasn't here, but from what I understand, you guys worked on some practice tests, and then you guys reviewed your practice tests to get a vibe of where you were, right? So, a little bit on that. So the practice tests and kind of keeping track of where you're going is really important because you do not want to waste time when you're prepping for this test, right? Because there are things that you are going to be super comfortable with, right? So let's suppose that you're amazing at vocabulary questions. You don't want to be spending 10 million hours on vocabulary questions when you do independent practice. Hold on, let me stay in here. You don't want to be like spending 10 million hours on vocabulary questions once you're already done that, right? And then the other thing is keeping track of your progress, right? This is a marathon, it's not a sprint, right? Getting a good SAT score doesn't happen overnight. It's, through weeks of work that little by little you're going to start improving. To the point where then you're going to be able to see the score reflected that you want to see, right? So what we're going to be doing today is that we're going to be focusing on both the English and math side, like targeting specific areas. English has a really great lesson plan today, and then for math, I'm gonna upload it right now to the Zoom chat because I know some of you don't have access to Google Classroom. I sent you guys a digital copy of the first 63 parts of this book, right? So this is my favorite SAT math book. So the way it operates is it divides the entire test into 63 topics, right? And it basically gives you some of the hardest problems it could give you for each of those topics, right? So some of that weird stuff that you see on testing, you're like, what the hell is this? This is what this book has, right? So what we're going to be doing today is we're going to be doing our English lesson, and then we're going to transition into our math lesson. And I really want you guys to follow along because this book also has like important formulas, drawings, diagrams to also help you out as we go on. We're going to be doing all these problems together, and then once we finish like the 63 tips, I don't know how long it's going to take us. It's probably going to take us like maybe like 2 weeks. Then we'll do some more practice problems from this book, which are like some of the toughest problems you can do for math. But what I found is that even for people who weren't as strong in math, after they used this book, like they pretty much were able to do any single math problem, just because of the way that the book sets the problems up and stuff. It's very similar to where you're going to see on the hardest section of the SAT. And if you're able to do, the hardest part of the test, then at that point, you should be able to do some of the easier stuff, as well, right? Other quick announcements. So I know some of you applied for positions on the EqualScore team. So we're going to be reviewing applications this week. We're going to be sending you an email with more information about interviews and things of that sort. So if you applied for a position, make sure to stay tuned to your email because we're going to be sending you information on that. And then all of you should have gotten an email I sent out this morning. Just kind of like having like a weekly update. That's probably like the format I'm going to follow. At least every single Sunday. I couldn't do it last night, so I sent it this morning. I want to send a quick email to all of you with like everything going on in the week and all the events we have going on. Starting kind of in the next couple of weeks, we're going to be adding a couple different sorts of like events and things like that you can attend, like webinars, and different content. So that's like going to be the place where you're going to be able to access all of that. This week we have on Friday office hours from 9 AM to 1 PM. So if you have any questions about college applications, the Common App, your college essay, specific things about the SAT, anything that you might need, we're going to be doing virtual office hours from 9 AM to 1 PM. So in the email that I sent out, you will be able to access that. So you would have to book a time, like it's a 20-minute time slot. If you feel like you need for some reason more than 20 minutes, then like book more than one slot, but. I mean, most people haven't been meeting with like the full 20 minutes, at least we need last week, but. It's really, really important that you guys take advantage of this because it's a great opportunity. I'm gonna try to do these, probably every Friday. But we'll see, depending on also how many people, if all the spots get booked, then we might open up more times and such, right? With that said, I think that's everything for like general announcements and things that you guys should be looking forward to. With that, I'm going to transition over to Kimberly, who's gonna start us off with.
We published the rooms already, so.
Okay.
We should just.
Okay, so do you wanna start? Today we're gonna start, so okay, on Zoom, you guys are gonna stay on Zoom and you guys are gonna start with Kimberly doing reading, and then all the people who are with me in person, we're gonna go to the other room, we're gonna start with that, okay? Alright, awesome guys, I'll see you guys on Zoom in a couple of minutes when you guys transition over to that.
That's okay.
Hi. For the ones online, for the math part, are we gonna be switched to a separate room or we stay here?
Yes, you're gonna be switched to a room.
Okay, thank you. We're here too, but they're helping me, so sorry for the camera. I have about 7 kids.
Okay.
Yeah.
Okay, so give us 1 second, we'll be starting at around 9:15 or so, okay? Hey guys,
You guys hear this?
thumbs up if you can hear me. Where is my? Thumbs up or chat if you could hear us, please. Perfect, I see your thumbs up, thank you. Okay, guys, so just a little introduction of what we're doing today. As Fabio already explained, last week we took a practice test. You guys did very well. But this week we're back into the routine of, teaching, learning, practicing. So today what we're gonna focus on, or this week, better said, what we're gonna focus on is the command of evidence type or style SAT questions. Now there's two different types of these questions. There is quantitative and
There's quantitative and
And-
there's, well, they call it by different things, because before they had like a different standard, but like, basically, all you have to know is there's gonna be like graphicals or numericals, so think like charts, graphs, anything with numbers and stuff like that. And then there's gonna be your like paragraphs, your scientific,
Right.
kind of answers.
So today, Monday, what we're gonna focus on is the quantitative side of these questions. So we're gonna look at all different types of charts and graphs and bar graphs or plots, all those type of things. On Wednesday, we will be focusing on the more text focused and paragraphs and sentences part of these questions, okay? So today's gonna be full of charts, so get ready for that. But before we start, we wanna start instituting this new little fun thing, just as a little warm up, a little preparation for what we're about to get into. We're gonna start with an SAT word of the day, alright? Pretty sure you guys could see, maybe it's not that big, but I wrote it on the board right beside Abraham. So the SAT word of the day today is methodical. Do we know what methodical means? Okay, Evan or Elijah, one of you.
I have under. If you're methodical, you are very careful about what you do, and you do it in measured steps according to a pre-described method.
Okay, wonderful. Elijah, did you wanna add on, or do you think Evander's perfect? He was well spoken? Okay, pretty much, guys. So if you're methodical, absolutely, you take the precautions, you do things with, a thought behind them, you're not spontaneous, okay? So if you're methodical, every step you take has a reason, okay? You have a purpose or a reason behind everything you do. So for any of you guys who didn't know, I'm gonna put it in the chat just so you can search it up, but we will be getting started now. Okay, and this is gonna be on our Instagram. Always follow our Instagram. If you just need extra reinforcement on what this word means, please look at our Instagram later on today.
Alright, so we're gonna be starting with a hard question, so we're gonna kind of start going away from what we did previously where we had like easy, medium, hard. And the reason that we're doing that is because in the practice test that you guys just took, they're not gonna organize it as this like easy, medium, hard, they're not gonna show you that progression. And we wanna get you guys used to kind of just seeing everything anywhere all the time. And we also wanna show you guys how like, maybe after like a difficult question, you'll get like a little easy break, right? So this is kind of an introduction, but again, since it is difficulty 3, it may be a little hard. But I'm gonna try and see if we can break it down. So the question itself says, in the United States, firms often seek incentives from municipal governments to expand to those municipalities. A team of political scientists hypothesized that municipalities are much more likely to respond to firms and offer incentives if expansions can be announced in time to benefit local elected officials than if they can't. The team contacted officials in thousands of municipalities inquiring about incentives for a firm looking to expand and indicated that the firm would announce its expansion on a date either just before or just after the next election. So really quickly, let me. Okay, so first things first. I'm gonna just kind of break this question down and then ask you guys for some input. In later questions, we're gonna have you guys like kind of tell me like general trends that you see on the graph. But for this one, I'm gonna kind of break it down for you first so you can see what I expect. So first things first, what are we looking for? So the political scientists hypothesized that, so this is like their conclusion, this is what we're either gonna like refute or we're gonna agree with or we're gonna support, right? They said that municipalities are much more likely to respond to firms and offer incentives if expansions are announced in time to benefit local elected officials. So over here, we have announcement before election, announcement after election. If you offer something, if you wanna offer like an incentive or an expansion or whatever, right? And you wanna announce it in time, it means you're announcing it before, right? So this means that we're looking for the announcement before election. So they're saying that they are much more likely to respond, so we should see much more or much higher gray bars than black bars, okay? The team contacted officials in thousands, this is just like the basic information section. And we are looking for the choice that weakens the team's hypothesis. So what are we looking for? We're looking for data that kind of says, no, the gray bar isn't higher than the black bar for each of these categories, right? So let's look. So A says a large majority of the municipalities that received an inquiry mentioning transparent announcement before the next election didn't respond to the inquiry. Can anyone tell me how we feel about A? Can I see like a thumbs up, a thumbs down? Again, this question is hard. I don't expect you guys to have like to be like dead set on your answer already, but I just kind of want to see where you guys are at. And for anyone with your cameras off, I know there's like a thumbs down like little emoji that you can do. So if you guys could do that as well, that would be appreciated. I saw Evander with a strong like thumbs down. Do you want to tell us why?
Because they do respond to the. This is right, as in it is what's in the graph, but it's not the answer to the question. It's the right answer to the wrong question, because a large majority of municipalities didn't respond to the inquiry, but that doesn't weaken the hypothesis. We're not talking about if they respond or not. We're talking about if they respond or not, depending on if it's before or after. And they look pretty much the same, so A isn't right.
Precisely. So I wanted to kind of, the reason that I wanted your guys' input for A is because you're gonna see a general trend when it comes to these difficulty 3 questions, and that's that you're not gonna have quote unquote wrong answers when it comes to deciphering the graph, right? So there might be answers that are like blatantly wrong, like you look at the graph and you're like, there's no way, like it doesn't correlate at all. But there are gonna be some answers, and in this case, in the hard difficulty, it's gonna be a lot of them, that they're technically right, in the sense that they do show what's going on here, right? So if you look, right, a large majority in both categories didn't respond, right? So you might be like, okay, well, A is right. No, because it doesn't answer the question, and the question is, what weakens the team's hypothesis? And their hypothesis is that one is much more likely to to respond to firms that are not and offer incentives if the announcement is made before versus after the election. So we will be looking at responses, and we will be looking at before and after, so the gray bar and then the black bar, and we'd be expecting the gray to be higher, right? That's not what A is saying. A is talking about no response in general. That's not gonna weaken the hypothesis. It's a correct observation, but it's not the answer. And then B, the proportion of municipalities that responded to the inquiry or offered incentives didn't substantially differ across the announcement timing conditions. How do we feel about B? Okay, I'm seeing a strong thumb up from Elijah, really, really fast. Elijah, do you want to tell us why?
Because sorry if my voice isn't the best today, because B says the proportion of municipalities that responded didn't differ across the various time conditions. However, the assertion that the political scientists made said that it would strongly differ. However, there's no strong difference on the graph, meaning that the political scientists were wrong, and B is how you can prove that.
Exactly, okay, so Elijah hit it right on the head. So basically, what this is saying is that if the scientists were correct, then we should see that the response and the incentives would be higher would have higher grade bars, right? Because the idea is that since they announced it before the election, they had more of a chance to respond and to offer incentives, right? That's what the scientists are saying. But B is saying that no, B is saying that it didn't substantially differ. Even if you don't know what substantially means like really large, like really big difference, right? Even if you didn't know what that means, differ, right? They're just saying it didn't differ, right? So they're just saying there wasn't that big of a difference, right? And if you look at the graph, A is right, meaning like if you look at the graph, you can see there isn't that much variation. And then B, you can also see that this weakens the census hypothesis, because if you're expecting this crazy turnout, if you announce it before the election, then the bar before should be crazy high, but it's not, it's the same as when they announced it after, right? So that's why B is our answer. I'm gonna breeze through C and D, because if you were, on a text question of the SAT, you would read option B, you would say, okay, well, that's it, and then you would revisit it if you have time. But again, I wanna get you guys used to kind of like breezing through these questions. So C, only around half the municipalities that responded to inquiries mentioned plans for an announcement before the next election offered incentives. So this is technically correct, and this is why I also pointed out A, right? If you look over here, that is about half. So here we have about 100, and then they responded to inquiry, we have about 200, right? So it is correct, it's a good observation. But we fall into the same issue that we found with A, which is that it doesn't respond to the question. And then if we look at D, other municipalities that received an inquiry mentioning plans for an announcement date after the next election, more than 1,200 didn't respond, and only around 100 offered incentives. One way that you can quickly eliminate this answer is the fact that it talks about a lot of non-response, which we're not looking for. We're looking for the responses themselves, and we're looking for differences in those responses. We see that in this answer, there's no comparison between those responses, so there's nothing saying they were really different, they were about the same, there's no kind of comparison. And then B, they're talking a lot about non-response, and that doesn't really fit what we're looking for, because we're looking to see if the response matched the announcement, so we're kind of ignoring this first section, right? So that's how you would solve this. The answer again was B, so you're gonna see that now. As always, we have our explanations, feel free to like go over them later on, but if you have any questions, I suggest that you ask us as opposed to like rely on these. This is an easy question, so you guys are gonna have a much easier time with this one if you found the last one hard. And yeah.
Yeah. Let's just, read this little description, okay? Or honestly, you could go either way. You could read the description, look at the chart first, then switch over to the description. It's honestly, your preference, but let's just read the description. So it says, to make sure they got the nutrition they needed while in space, the astronaut of NASA's Gemini missions were given menus for 3 meals a day, meals A, B, and C, on a 4-day rotating schedule. Looking at the sample of food items from these menus, a student notes that on day 1, the menu included. So obviously, just by reading this description, we know what we're looking for, what we're supposed to look for, what we're being asked, okay? What did the menu include on day 1? Honestly, this sentence here just takes up space. It's just filler. Don't get your mind too hung up on it, okay? Look for what they're asking, and it's in the last sentence, okay? In the sentence you're supposed to complete. It's looking for what the menu included on day 1, okay? So, let's look at this, this table, this little chart, okay? So it's the sample of food items from Gemini mission menus, okay? So on the left side, it gives us the food item, and then it gives us the day of the meal, okay? Reading all that, seeing that sugar cookie cubes were given on day 1 and they're part of meal B, that chicken and vegetables were day 2, part of meal B, shrimp cocktail was day 4, part of meal C, and hot cocoa was day 3, meal A. Given that, what is the answer? Would it be A? Do we think it's A? Yes, no, maybe you wanna send it in the chat, we have people on the chat, so you could send it. Do we think the answer is A? No, I have a no.
They're saying those in the chat.
No, okay, absolutely not, guys, no. If we look here, where's shrimp cocktail? Let's look back, let's just, not only is it incorrect, but let's see why it is incorrect. So we look back, shrimp cocktail was actually on day 4, okay? It's not asking us about day 4, we're being asked day 1. So automatically, you look there, that is incorrect, okay? What about B? No, I have a no, perfect. Absolutely not, okay? We just look here, when was hot cocoa given? On day 3, we're again looking for day 1. Even though, and matter of fact, hot cocoa was given for meal A, not meal C, just like shrimp cocktail was given for meal C, not meal B. So the answer in and of itself is incorrect, but even so, further on, it doesn't even answer what we're, being asked, okay? So honestly, as soon as you see the answer in and of itself being incorrect, you already know that that is not the answer, okay? That is not the answer. So no, what about C? What do we think about C? Yes, Avenger said yes. Thank you to everyone. So absolutely, it is C. Now let's see why. If we look here, you can tell clearly on day 1 for meal B, sugar ice cubes were given. So C is the correct answer. But let's flip through D. Let's not, just completely slide over it. Meal D, sorry for the noise, guys. Meal D, answer D says chicken and vegetables for meal A, okay? Again, chicken and vegetables are given on day 2 and they were for meal B, not A. So absolutely incorrect. The answer is C. Do we have any questions? I will be showing the college board and then I'll be doing one more question. Okay? Anything, remember, I'm pretty sure we're gonna post this on Google Classroom. I'll strive to post this on Google Classroom. You guys could always go back and check if you had a question. So. Yeah. Okay, so yes, C. Okay, so that was it. Oh, sorry. What did I do? Okay, so we just did a easy question. Now this one is a hard question, okay? We want you guys to just get exposed to these like altering question difficulties because, it just, oh no. Where did it do that? Can't see D. Can you guys see answer choice D here? Can you go on there and make it smaller? Can you guys see answer choice D? No? Okay, we're gonna fix that right now. Any other question?
You're on economic.
Oh, okay, wait.
Wait.
Okay, can we see it now?
W.
Yes? Okay. Yes, thumbs up. Perfect, okay. Sorry about that. But let's start. Okay, this is hard difficulty, okay? Let's read the little description they're giving us right here. High levels of public uncertainty about which economic policies a country will adopt can make planning difficult for business. But measures of such uncertainty have not tended to be very detailed. Okay? So they're telling us, public uncertainty, high levels of it makes planning difficult for businesses, but such measures have not tended to be very detailed. Okay? Recently, however, economists, whoever, analyzed trends and news reports to derive measures not only for general economic policy uncertainty, but also for uncertainty related to specific areas of economic policy like tax or trade policy. So right here, they're telling us that this economist just analyzed trends for general economic policy uncertainty, but also for other areas of economic policy like tax and trade. One revelation of her work is that a general measure may not fully reflect uncertainty about specific areas of policy, as in the case of the UK, where general economic policy uncertainty believed. Okay, so she had a revelation, and it's that A general measure may not fully reflect understanding about specific areas. Okay, as can be seen in the UK, where general economic policy blank. Okay? So now we're gonna just look over this chart and see what it's telling us. Okay, so the chart is telling us the economic policy uncertainty in the UK between the years of 2005 and 2010. Okay, we have the year over here, and you know, on the x axis and y we have uncertainty, which is categorized as larger values equals more uncertainty. Okay, so let's just look at what we're seeing, and the trends that we're seeing, trade values in trade policy, had a lot of uncertainty in 2005, and tax and public spending policy had a lot of uncertainty in 2010, okay? That's just some things we can just observe right off the bat. It's just something surprising, it's always good to point something that's, very standoutish, okay? You can see it stand out. Okay, so let's start going answer choice through answer choice and reviewing what we think could be the correct answer. Okay, A says, aligns closely with uncertainty about tax and public spending policy in 2005, but differed from uncertainty about tax and public spending policy by a large amount in 2009. So, reminder, we're looking for general economic policy uncertainty, which is categorized by this very, very dark shade. Black, I guess it's not even a shade, it's just black. So that's what we're looking for. Is a possible answer choice. Does A make sense? Take your time, this one's a bit difficult, so don't worry. Evelyn, you say no, or is that old? I'm not sure. Is that a no? It's in, oh, Evan said no, okay. Evan, why do you think no?
Because it doesn't align closely with uncertainty about tax and public spending policy in 2005. Trade, hold on, wait, I'm getting confused. I can't see apparently. I'm blind, I guess.
I would make it bigger, but it's honestly not gonna fit. So, okay, don't worry about that. You just keep trying to see if you can see. Okay, so we're gonna say that A is no, but we'll come back to it. Okay, we'll say that it's a no. Okay, but they're asking us about general economic policy, okay? It can't really, let's see, it says that it's aligned with uncertainty about tax and public spending in 2005, okay? Did it really align? I mean, not exactly, okay? So, and then deferred from uncertainty by a large amount in 2009. Honestly, this is not a large amount. If we see that, that's honestly very, very close. They're trailing behind extremely closely, okay? So, this is again, like, very chart heavy. You have to be able to, know what the chart is saying, okay? It doesn't align, okay, honestly, let's say it does. It kind of does align closely in 2005 with, tax and public spending in 2005, obviously, as we see here. It does align closely, right? Let's say that it does align closely, but the second half of the answer choice says that it differed by a large amount in 2009. Honestly, it did not. It looks very close. Again, it could align very closely, like the answer choice just told us. It did not differ by a large amount, okay? So even if we're not sure about it, let's say A is a no, possibly maybe, okay? But, let's keep looking through our answer choices. B was substantially lower than uncertainty about tax and public spending policy each year from 2005 to 2010. Do we want to put in the chat what we believe? No, we don't know, we're confused. Okay, that's fine, guys, don't worry, I know, it's early. So. B says, okay, that the general economic policy was lower than the uncertainty about tax and public spending. So tax and public spending is this like median shade, the middle shade between these three colors, okay? So it's saying that general economic policy was always lower than tax and public spending policy, so that this black shade was always lower than tax and public spending policy. Let's go through each year and try to verify whether that's true or not. Elijah, I see your thumbs up, okay? And Evan, I see your X, I see, okay? I also believe that it's incorrect, but let's review it. Thank you for the people that did think it was correct. Okay, so let's go through 2005 and let's see if I could just clear these drawings so it doesn't confuse us, okay? Okay, right. So we're looking at this blackboard. Okay. Absolutely. In 2005, it is lower, not substantially lower, but it is lower, okay? So, let's just keep looking, let's keep verifying because it says each year, every year, okay? So let's keep going. In 2006, it's higher, okay? This tax is higher, the uncertainty about this tax is higher. In 2007, once again, it is higher. In 2008, it is slightly higher, but higher nonetheless, okay? And as we keep going, we see there's a pattern. It is higher until we get to 2010, where tax and public spending policy does soar over general economic policy. However, what is the answer choice telling us? It's telling us that it was substantially lower every single year. That is absolutely incorrect, okay? Do we see why this is incorrect? Do we see why? It wasn't, even if it wasn't always substantially lower, sometimes it was higher. So that in and of itself makes the answer choice wrong, okay? Good? We'll move on. If anything will come back, I think we're good. B is incorrect. C. Let me try to erase this so we don't get confused again. So, C. Reached its highest level between 2005 and 2010 in the same year that uncertainty about trade policy and tax and public spending policy reached their lowest levels. What do we think? This one was a bit wordy, might confuse you a little. What do we think? Anyone want to tell me in the chat? Is it like a maybe, possible, answer choice? No. Okay, a thumbs down. Perfect, no, I see it. Perfect, thank you guys for being, very active. I love this, okay? So, I absolutely believe that this is not the correct answer. But, let's not just say that and move on. Let's, come back and see why it's incorrect. So, when did general economic policy reach its highest level between the years of 2005 and 2010? Can you guys let me know in the chat? What year did general economic policy uncertainty reach its highest level? We have an idea? So I see it 2010. 1 second, guys. I see it 2010, I see it 2010. Yes, I see a lot of 2010s, okay? Obviously, this is the highest. If we draw a straight line, this is the highest point that general economics policy reaches. I believe I saw 2007. That would not be the correct answer. I'm not sure if that was a misinput or maybe, we just got mixed up. But if we look at the chart, general economic policy peaks in 2010, okay? That is its highest point, okay? So, okay, just saying that. 2010 is when General economic policy uncertainty reaches its highest point. But it's also telling us that in that same year that it reaches its highest point, so 2010, it's telling us that trade policy and tax and public spending policy will reach their lowest levels. Is that true? I don't think so. Absolutely not. Because, I mean, we can tell right here that tax and public spending policy reaches its highest level in 2010. Okay, so that is absolutely incorrect because how is it going to reach its highest level when the answer choice is telling us that it reaches its low level? Okay, and while maybe you get confused because trade policy does look fairly low, tax policy is not low whatsoever. It's honestly higher than general economic policy uncertainty. Okay, don't get mixed up. Look at everything, think everything out. Don't just look at one factor of the answer choice and automatically pick it. Do we see why C is incorrect? If anything, keep chatting. I'll keep checking. Okay? So with that, the answer choice is most likely going to be D, but let's review it, okay? D was substantially lower than uncertainty about trade policy in 2005 and substantially higher than uncertainty about trade policy in 2010. Do we think this is correct? Even if we didn't know it was the answer, do we think it's correct? Yes. Reina, would you like to tell me why it's correct? From your perspective, from your point of view?
Yeah. In 2005, it was way lower than trade policy. In 2010, it was higher than trade policy.
Absolutely. We can see that right here. Okay? You are correct. That's honestly what you can view. There's not much to it. There's not much assumption. It's just what we're viewing. In 2005, you see this little black one, very low, while trade policy is extremely high. We were saying maybe around 90, 80 for general economic policy and around 150. Okay, so very big gap. Then 2010, it shifts. Now we see that trade policy has close to let's say, I don't know, not even, barely 100, okay? Doesn't really matter exactly, they're not asking us for exact uncertainty values. And then we see that general economic policy is reaching, again, barely 100, okay? So absolutely, Reina, you were correct, good job, pat on the back. Love that smile, makes me really happy. Okay, this is the correct answer, do we all understand? I'm gonna put the College Board explanation and we're pretty much okay. Perfect. So D, so again, guys, if you want to take a picture of it, but or we could come back to it later on, but this is always gonna be posted. And this is the next answer. I mean, not answer. Next question.
So funny story, it's not the next question because we did go over this one, because this one was one of the first ones that we did. Remember it was the escape velocity one, maximal speed, escape velocity, energy, yeah.
I think I did this one.
Yeah, you did do this one. So basically, guys, this is one of the ones that it isn't a category, but we did go over it in kind of one of those mixed reviews. So I'm not gonna spend time covering it right now. If you guys recognize it, and remember having any questions on it, the answer is B. Again, if you guys have any doubts or wanna try it again, you can. I mean, you can either do you can either go on the SD question bank and find it with the ID there, or see if it's in the other side that we posted. You guys can do it yourself. Let me know if you have any questions, through the chat or later on, but we're gonna skip it for now for the sake of doing new questions. So this one's mid difficulty. I believe the next one is as well, but don't quote me on that right now. So it's not gonna be too crazy hard, not gonna be that last one. That last one I know was crazy. But don't worry, this one's gonna be a lot better. I believe you guys can see all the answers? Can you guys see all the way to D? I'm just making sure, cause, okay, yeah, awesome. Okay, so yeah, so let's begin. So the Jordanelle Dam was built on the Provo River in Utah in 1992. Earth scientist Adriana E. Martinez and colleagues tracked changes to the environment on the banks of the river downstream of the dam, including how much grass and forest cover were present. They concluded that the dam changed the flow of the river in ways that benefited grass plants but didn't benefit trees. And then we're looking for a choice that supports the conclusion. So we're not looking for anything that goes against it, we're looking for something that supports, okay? And here we have the three categories, so our like mid-gray is grass cover, our light gray is bare soil, and then our like, I don't even know, black is forest cover. So when you have a question like this where you have like a pretty easy trend, so our trend being that we're looking for a benefit to grass plants. And then either like no benefit or anything like a harm to the trees, right? We wanna start thinking of what that's gonna look like in our minds, right? And the reason I say that is because sometimes if you like start reading an answer and you're not super sure, you're gonna start like second guessing yourself. And if you have a clear picture of what you think the right answer is gonna be, it's gonna be easier, like when you find it, to be confident in it, right? To be like, okay, yeah, this is the answer, we're gonna move on, right? And again, as it's a time test, we wanna prioritize that. So if we're thinking, right, that something is gonna like benefit the plants and not benefit the trees, what are we expecting here? We're expecting some kind of growth in grass cover, some kind of increase, right? Because we're expecting more grass, that's what grass cover means. And then we're expecting some kind of change to forest cover as long as it's not an increase. So we're expecting either like relatively the same, you know, it's gonna go a little up or a little down, because the SAT tries to be somewhat realistic. So they're never gonna be exactly the same, but it's either gonna be like a little up and a little down, or it's gonna be like very, like a huge decrease, right? That's what we're expecting, that's what we're looking for. So let's look at our answer choices. So A. The lowest amount of grass cover was approximately 58,000 square meters, and the highest amount of forest cover was approximately 75,000 square meters. What do we think about A? I'm seeing a no from Catalina, no from Evander in the chat, okay. This one was like a really fast no, so I don't think we're gonna spend too much time on it. It is just kind of like a fact, right? So, not only is it like just like a plain fact that isn't really relevant to our question, but the way that you can tell that this is something that like isn't super applicable is the fact that there's not a real comparison here, right? It's not saying this increased, this decreased, right? It's not saying this increased more, this decreased more, this right? Because at the end of the day, we're comparing grass and forest in some way, shape, or form, but there's no comparison here. This is a fact about grass, this is a fact about forest cover, but it's not using that to support the argument. And then if we look at the fact itself you can see is irrelevant, right? Because it just says that the lowest amount of grass was 58,000. It doesn't say when it was, right? It could have been over here when forest cover was at its lowest, right? And the highest forest cover could have been at the beginning, right? It doesn't give us time, doesn't give us date, it doesn't show us that effect of the change in flow of the dam. So that's why A is wrong. I'm not gonna spend like too much time on it if you guys are pretty sure about your answer. Let's look at B. There was more grass cover than forest cover in 1987, and this difference increased dramatically in 1993 and again in 2006. So how do we feel about this one? I'm seeing no from Carolina, no from Zadel, no from Sahara, no from Evander. Can one of you just unmute and tell me kind of why you don't think it's B? I'm just kind of curious to see you guys' reasoning. Maybe from somebody different, so like Sahara or I think Carolina.
So right off the bat, it says there was more grass cover than forest cover in 1987, which is clearly false from the graph, and that already immediately throws off the entire answer choice.
Alright, that was exactly what I was looking for, thank you so much. So I wanna show you guys that even if something theoretically is correct, which if the difference increased dramatically, right, then you can assume that they're referring to like, oh, so there like, you know, there's way more grass later on than there is forest cover, which would support this idea that they said, right? However, the first part is already wrong. So with the second part of the answer, they try to trick you, right? But you're always trying to go back to that graph, right? You're trying to reference the graph. And because the simple fact of the graph is wrong, the entire answer is wrong, right? So that was a quick elimination that you could have done in like a few seconds. So that's awesome. Let's look at C. There was less graph covered than bare soil in 1987, but more graph covered than bare soil in 1993 and 2006. Whereas there was more forest covered than bare soil in all 3 years. Anyone have opinions on that? Yes, no, thumbs up, thumbs down. I can see your guys' like screens, like, so you guys can do the emoji or you guys can do the chat, I don't really mind, I'm seeing a lot of no's. Alright, okay, well, this is awesome, you guys are doing really good on this question, it is a big fat no, alright. So first things first, one thing I wanna signal is, they're comparing grass and soil, and then forest and soil. Theoretically, right, if you do enough of these like connections, right, you could compare grass to forest. But the SAT isn't testing your like crazy like logic, right? They're trying to test whether or not you can interpret a graph, right? And if we're looking for a comparison between grass and trees, we're looking for a direct sort of like. This went up, this went down, this did the same, this did, right? That's how the SAT is gonna kind of phrase these questions. Even the more complicated questions, like the one that you guys just saw, difficulty 3, right? They clearly said like, this category was higher than this category was higher than this category. They're not gonna have you do these crazy like, you know, one is greater than this, greater than that, better not, right? But right off the bat, by the fact that we're seeing these like crazy comparisons that aren't related to the actual problem, you can kind of eliminate the answer. And then another thing, right, is that you wanna be careful of when they say like a little, so for example, here when they say. Had less in 1997, more in these days, but then forest cover had higher in all 3 years, right? They're giving you all these crazy numbers. The SAT is not trying to test you to like. To analyze like the entire graph in the entirety, this isn't a summary. Right? This is a question about using data to support the graph. So even if this is like factually accurate, which I'm not gonna like go and bother and check, right? Even if this was an accurate statement, right off the bat, we can tell this is like a summary statement, right? This is kind of a summarizing this graph, but it's not making a point with it. Whereas if we check D, which is our answer, it actually takes specific parts of that data to support the Martinez and colleagues. Which is the fact that it said that grass cover increased and forest cover decreased, which A aligns with what we originally thought, right? Because again, if we're benefiting, we're expecting an increase to grass and either no increase or a decrease to forest. And B, it is data, but it's like very specific like little nitpicks, right? And that's what we're trying to do, right? So with these questions, I would steer clear of summaries if you see that if you're between, again, this is like a time crunch advice, I don't expect you to do it all the time, but if you're in between 2 answers. And one of them is very summary like, and one of them is a quick kind of like, okay, takes this piece, makes a conclusion. I would always go for the kind of like nitpicky answer, because we're trying to interpret data, we're not trying to summarize it, right? That's the point of this question type. I'm gonna do one more with you. I was right, it is the same difficulty, which is good. You guys seem to be doing pretty good with these, which is awesome. These and the cross-text connections are kind of, I would say, the most difficult question types that you guys are gonna see on the SAT. So if it's not scaring you now, it's not gonna scare you when you actually take the test, okay? Right off the bat, I'm seeing this. What does this tell me? They are throwing weird scientific terms. Is this a science test? No, it is not. So you know what I'm gonna call this DA. I'm gonna call this CQ, and I'm gonna call it A. There's no need to be like repeating all these crazy names, that's not what the SAT is testing us on, okay? So I wanna handle this one a little different and kind of just, can anyone unmute? And I'm not gonna like, I'm just gonna like ask you some questions about the graph. So like, don't be afraid, I'm not gonna like come after you. But maybe, I think Sahara is pretty active in the chat, or Reina. Someone other than Evander and Elijah right now, just because you guys participated a lot. Thank you. Maybe, yeah, Reina, could you unmute for a sec?
Yeah.
Thank you so much. It's gonna be just like a few questions about like kind of what you see in the graph, right? Because a lot of the time, what we see on initial impressions is gonna be important, right? So what are we seeing between these two numbers, right? So in like row 1 and row 2, right? What are we seeing? Are we seeing an increase, a decrease? Are they kind of staying the same?
We see increase.
All right, we see an increase, awesome. And then in this third column, what do we see? Well, we're correct, there's an increase. And then we're seeing two percentages. Can you tell us if maybe one's greater, one's less? Which one is greater, which one is less?
CQ is greater and DA is less.
Yeah, I'm really sorry about like my handwriting here. This is meant to be an A, but whatever, okay. DA. So I have another question, right? If this is percent increase, even though row 2 increased by more, did row 1 also increase or did it decrease? Because like it's less, but did it still go up?
Yeah, it did go up.
Okay, that's gonna be important. Thank you so much. You can mute.
You're
yourself.
welcome.
Okay, so let's actually read the question now. The only flowering plant species native to Antarctica, CQ, and DA, grow in places where the earth remains free of ice for much of the year. Botanist Nicoletta Canone wondered how the warming of Antarctica's climate in recent years had affected these species. So she visited a site in Antarctica, at first in 2009 and later in 2018 to count the number of plants growing there. Canone found that the area of land covered by the two species had significantly expanded during the 9-year period. So I'm gonna note this, that significantly expanded, which we see in the graph. While both species likely benefited from warming temperatures, CQ blank. Alright, so right off the bat, we're seeing a comparison, right? Because it's saying while both blank, CQ blank. And we just talked about this, right? They both went up. We're acknowledging that they both increased. But we're already seeing that there's a difference in that increase, right? So CQ is going up by a higher percentage. Okay, so let's make a mental note of that. So let's look at A. Suppress the growth of DA, which covered a smaller area of land in 2018 than it had in 2009. How do we feel about A? Is there, okay, I'm seeing no from Sahara. Sahara, you're pretty quick today. No from Carolina. No from Evelyn. All right. So I'm not gonna spend too much time on this question. Right off the bat, right here, which had a smaller area of land in 2018 than it had in 2009. Did we not just say that there's an increase, right? Like, I mean, look at the graph, right? Both of them go up. Both of them go up. So what does this mean? Just for the fact that there's this little fact, this entire answer is wrong. And you want to be looking for these things because the facts allow you to quickly eliminate these answers, right? And then the other part, so this first part, we have no evidence that one increasing prevents the other, right? There's nothing here about like some chemical that it secretes that's poisonous. There's nothing about that, right? And when it comes to the SAT, they're not gonna ask you to make these crazy wild assumptions because you're not a scientist, right? You're a reader. So that's why A is, let's take a B. So a greater expansion than DA did, increasing the area of land it covered by more than half. How do we feel about B? I'm seeing yes from Zafiel. I'm trying to look at the top, but like I can only see it as they come up. So yes from Catalina, yes from Reina. Okay, yes. So our answer is B. This one's great. This one was pretty nice to us. The answer was the second one. But so what did we say before? That we had a greater percent increase, and that's exactly what we see here. We have a greater expansion. And then we always want to pay attention to the second part of the answers, just because again, if the second part, if the fact of it is wrong, the entire answer is wrong. But if we look over here, this is 55. 55 is greater than 50%. 50% would be half. So this second part checks out. The first part checks out, so the entire answer checks out. Our answer is B. I'm going to quickly go over C and D. So C showed a greater increase in the average size of individual plants. Right off the bat, we can eliminate this. Why? There is no mention here of individual plants. They don't say that they did a test with like 5 little pots and 5 little plants and they grew. No. This is talking about huge areas of land in square meters, right? They're talking about individual plants, irrelevant. And then D, covered land newly freeze and mine at a rate 55% faster. Alright, that's also wrong, and the reason that it's wrong is because we're looking at a percent increase in area coverage. So you're gonna want to pay attention not just to the numbers, but to what they're saying the numbers are, right? So they're asking you for numbers in context. That's kind of how you want to interpret this quantitative data, alright? So again, our answer was B. If you have any questions, feel free to put it in the chat, but I feel like I think I do pretty well with at least the mid-tier questions. And I think I'm gonna hand it over to Kimberly for, I don't know what kind of difficulty, maybe
I
hard.
think it was hard, yeah, guys.
Good luck,
A
y'all.
lot of hard. Definitely annoying. I don't know where the next one would be. Oh, I think there's one there. Okay. Let's see. Okay. Wait, this is not going to sit well.
Get the ball.
Beef.
Mhm.
Okay, so. Ooh, okay, wait, you guys can see that, right? It's not cut off. Good?
Yeah.
What, yeah. It's not cut off, yes? Perfect, thank you, Reina. Oh, D is cut off for you, okay,
I'll try that, don't worry.
let's do that. Okay, how do we,
Actually,
Thank you.
just make it everybody's kind of.
you could even like, just go ahead and let's not this. Are we okay? Hey guys, are we okay or is it still cut off? Is that deal or
I'm seeing
good?
thumbs up and check.
Good. Okay. Perfecto. So. Let's start reading civil description right here. Geographer, whoever, and his colleagues surveyed small-scale farmers in 3 locations in Ondo State, Nigeria, which has mountainous terrain in the north and an urbanized center and coastal terrain in the south. To learn more about the practices, like the types of crops they mainly cultivated, in some regions, female farmers were found to be especially prominent in the cultivation of specific types of crops and even constituted the majority of farmers who cultivated those crops, for instance. Okay, so what did we just read? So this geographer, okay, it doesn't really matter his name, he surveyed some farmers, okay, in 3 locations in Nigeria, which and gives us a description of the terrain in which these 3 locations are constituted of, okay? To learn about the practices and the crops that they cultivated. In some of these regions, female farmers were found to be especially prominent in the cultivation of specific types of crops and even constituted the majority of farmers who cultivated those crops. For instance, now we're going to look at the chart, just see a little breakdown. What is this chart telling us? Okay, so right here, it's telling us the percentage of all the state's small-scale farmers who are female by main crop row. Okay, right here it's telling us the 3 regions that were being studied and the 3 different crops that we have a key for it. The 3 different crops that were being looked at. Then we have it over here, the females as a percentage of the total small scale farmers. Okay? Do we understand what we're kind of being asked, what we're looking at, what this question constitutes of? Yes. Good? Let's see. Okay. I'll take that as a yes, everyone. We understand this question. So, let's see what A is asking us. Well, not what A is asking us, what A is telling us, okay? Most of the farmers who mainly cultivated cereals and most of the farmers who mainly cultivated non-root vegetables in South Ondo were women. Is this correct? Does this make sense to us? Can we see that from this chart? Yes, no, maybe so, we're asleep, we don't know. We're confused. It's okay to be confused, just chat with me, make this interactive. You don't have to unmute, but just give me some chats. I see a no by Zabdiel. Zabdiel, would you wanna tell me why it's a no? Maybe unmute yourself or just type it in the chat.
Can you hear me?
Yes, I can.
Okay, I think it's no because the information in the graph doesn't say or doesn't compare like the farmers who are female to farmers who are male. So you can't really compare that. Most of them in that area were female. You can so that part of the question A is incorrect.
Okay. Perfect. Okay, so answer choice A is likely not going to be the correct answer, but just in depth, going on what you said, Sabdiel, let's see exactly why. Thank you for sharing why you don't believe that A is correct. So we're gonna say A is no for now, okay? Maybe we might make it an option later on. So most of the farmers who mainly cultivated cereals and most of the farmers who mainly cultivated non-root vegetables in South Ondo were women. Okay. So we're looking at South Ondo right here, and we're looking at cereals, so this like medium grayish shade, and we're looking at this black non-root vegetables, okay? Looking at these two. Or something like this, just so you guys can see. Okay, so it's telling us that most of them were women, okay? Honestly, that's not really what we're being asked, okay? Because, the answer choice is asking us that, for instance, the female farmers were found to be especially prominent in the cultivation of specific types of crops, and even constituted the majority of farmers who cultivated those crops, okay? So if we look at it right here, we're seeing that the percentage of female farmers in South Ondo that cultivated cereals is around, let's say, 35%, okay? Knowing what we know, 35% is not really majority, okay? When you see 35%, do you think majority? I don't think so, okay? I really don't think so, okay? So this is one that you're really gonna have to just think about a little harder than the rest. It's not in your face, this is exactly why it's a difficult question, it is very tricky. It's not even based off assumptions, it's based off facts and what you know, okay? 35% is not majority, okay? You know, what do we think majority is? Maybe like 80, 90, 95, 100, okay? Something big numbers, but definitely not anything less than 50. Okay, so again, this is tricky. Do we understand why A is incorrect? Well, actually, let me review non-root vegetables. My bad, guys, sorry, I'm crazy. So, okay, we see that cereals is 35, but let's look at non-root vegetables. Non-root vegetables is pushing 55, let's say that it's 54, 53, okay? We could say, in this context, that is fairly close to majority, okay? Fairly close. Okay, there are more female farmers than male in this case, okay? But as we reviewed in the cultivation of cereals, it's not the case, it's only 35, okay? So just because one part of the answer does actually relate to what we're being asked does not mean that the whole answer choice is correct. Please always look at the entire answer choice, okay? Got it? If anything, we'll go back, but we're gonna move on for now. Thank you, Elijah, for that nod. So. Okay, B. More women in Central Ondo mainly cultivated root crops than mainly cultivated cereals. Okay, so now we're looking at Central Ondo. And we're saying here, let me just erase what I had previously, we don't get confused. We're saying here that women in Central Ondo mainly cultivated root crops. Okay, So we're saying that they mainly cultivated this right here. It's being shaded in purple right there. Okay? Then cultivated cereals. This is cereals, okay? So we're saying that they cultivated these squiggly lines more than they did this straight line. Is that true? Reina, do you want to answer for me? Wait, actually, no, Reina. Reina, you're perfect. You're amazing. Katerina, would we want to try answering this question? Are you here? Maybe Krishna? Krishna, you've been a little inactive. Very unlike you. Nobody? Are we all? Oh, let's see. Let's see. Okay. Very good.
I do not think it's B.
You do not think it's B? Oh,
Yeah.
Carolina, thank you for answering. I don't think it's B either. Would you want to tell me why, or that's just a lucky guess? Don't worry, don't worry.
Yeah. So B says more women in Central Anand mainly cultivated root crops than mainly cultivated cereals. That's clearly not true because it doesn't match up with the graph like at all because cereals is way higher than root.
Absolutely, simple as that. It does not match, it is not the correct answer choice. As you can tell, cereals is higher, cereals has about, let's say, I don't know, like 37%, while, root crops only has 20, okay? So cereals has majority in this case, therefore the answer choice in and of itself is incorrect, okay? B is not the answer. C, most of the farmers who mainly cultivated non-root vegetables in North and South Ondo were women. Okay, let's go back. So we're looking at North and South Ondo, and we're looking at only non-root vegetables. So right here and right here. I think it was Daniel, well, now you guys are telling me yes, but I first saw Daniel say C. I think it's Daniel Hernandez? Would you mind explaining to me why it's C, Daniel?
It's the only one that actually makes sense. And it also says that they were mainly cultivated non-root vegetables in North and South Ondo were women. So if you look at where it's at the side, with the percentages, like 57% was in North Ondo, which is the majority. And then if you look at South Ondo, it's around 52%, which is also the majority. So C is the one that makes sense.
Absolutely, yes, okay. C does make sense, okay? We're still gonna review D, but just like Daniel said, if we look over here, we obviously see not only can we just observe the fact that non-root vegetables are the highest in the graph itself, okay? They're like nearing this, plus 50 mark, okay? No other crop nears this plus 50 mark. But we see it near it here again, but it's only at 45, and yet again, it is a non-root vegetable, okay? But no other crop, such as the cereal or the root crops, nears this 50 plus, which is categorized as majority in this context, okay? So, and then again, looking at North Ondo specifically, we're gonna look at non-root vegetables. We go up here, it's absolutely high at 57, around there. South Ondo, again, we go up and it's nearing 54, 53, something like that. It is the majority, okay? Answer C is correct. But we're gonna look at D, okay? We always just wanna go through all the answer choices. In the case that you're running out of time, you really don't have time to look at D, you think C is the best answer, you go for it, okay? Because it's better to have an answer than no answer. But just because it's practice, we are gonna be reviewing it, it doesn't matter. So D, a relatively equal proportion of women across the 3 regions of Ondo mainly cultivated cereals. Do we think this is correct? So now we're looking at all 3 regions. Now it's not only 1 or 2, all 3. What do we think? We're looking at North London, Central, and South. And we're saying that an equal proportion of women cultivated cereals. Okay? So like. Okay, so I see no, it is not irrelevant or not. Okay, great. Maybe you look at D and you're like, well, honestly, in Central and South Londo, they looked fairly equal. They're fairly proportional, they look fairly equal. But then you look at North Londo and there's a significant decrease in the percentage of female farmers, okay? Remember, take the whole answer choice. Do not only take part of it, or part of it supports the chart, part of it doesn't support the chart. No, every single aspect of the answer choice has to support the chart. Okay, we see here that although Central and South Ondo could support this answer choice, it could make this answer choice true. If we look at North Ondo, it's showing a decrease. It is not as equal as these two others. Okay, so D is not correct. Okay, do we understand? Yes, no, maybe so, thumbs up.
Yeah,
Got it.
also, I don't know if this is relevant, but just a tip, because I see that with harder difficulty problems, you also have to look at like the question or like the blank besides the chart. You can tell in that sentence where it says female farmers were found to especially be prominent in cultivating a specific type of crop and constitute a majority of the farmers. That shows, okay, so they take up more amount of like farmers that there are, which is clear when you see North and South London. And they're specifically prominent in the cultivation of one, and that one crop is non-root vegetables. So that's how I interpreted it. That immediately made sense to me.
Absolutely.
Easier. I think that was easier than, when you're like on a time crunch.
I agree. Yes, it is absolutely easier. I couldn't have said it better myself. You were correct. Honestly, there was that way to look at this where there is, a more answer focus. I usually just like, honestly, because I am teaching, I have to go through all the answer choices and I can't just really give you the easy way out, but absolutely, Carolina, that was a very, very, very intelligent way to go about this question. Okay? Yes, absolutely. They are prominent in one crop, one specific crop, and then they constitute majority. That is what answer choice C is telling us with non-root vegetables in north or south. Okay? Absolutely. So, yes, Carolina, I actually really like that description. Thank you. We're gonna be moving on. I'm gonna show the answer. Oh, never mind. I'm gonna show the answer now. Yes. Perfect. Right, so here, honestly, this one is a little harder because they are asking you to do a little bit of an extra step that you're not really told you have to do. But you do have to keep in mind that anything below 50% is not the majority, okay? So just might seem common sense, but maybe day of the test, you get a little stuck, you don't think it's common sense, and we end up getting the question incorrect. Okay? This one was definitely, maybe for some was easier than others, but it is a hard question. Okay? But this is the explanation. Remember, we're gonna be posting this, so we're not gonna dwell on it too much. We're gonna move on. Okay, so, well, look at that, another difficult. I guess we just love difficult questions today, but this is good practice, so you know what, don't be weird. Let's look, it says, employing high performance liquid chromatography, a process that uses pressurized water to separate material into its component molecules. Astrochemists, whoever and colleagues analyzed 2 samples of the Murchison meteorite that landed in Australia, as well as soil from the landing zone of the meteorite to determine the concentrations of various organic molecules. Whoa, what did we just read? Okay, very a lot of word louder, okay? It's honestly a lot, okay, let's break it down. Okay, don't get overwhelmed, step by step, let's break this down. Ready? So. We're saying that we're employing high performance liquid chromatography, okay? That's what this chemist is doing, and it describes what exactly this means, okay? This chemist has analyzed 2 samples of the Murchison meteorite that landed in Australia and soil from the landing zone to determine the concentration of various organic molecules. Okay, we kind of broke down what we're gonna be looking at, what they're gonna be introducing us to, not only in this chart, but in the rest of this paragraph. By comparing the relative concentrations of types of molecules known as nucleobases in the Murchison meteorite with those in the soil, the team concluded that there is evidence that the nucleobases in the Murchison meteorite formed in space and are not the result of contamination on Earth. Okay? Again, let's break down what we read. Okay? So by comparing all the examples that they have, that are known as nucleobases, with those in the soil, the team concludes that there is evidence that the nucleobases formed in space and is not the result of contamination on Earth. So, you know, we can say that this was probably a belief that was held when this meteorite happened. Doesn't really matter, it's just telling us that it is not likely what occurred, okay? So let's look at the chart. The title of the chart is nucleobase concentrations from Murchison meteorite and soil samples in parts per billion. So here we have nucleobases, the meteorite sample 1, meteorite sample 2, and the soil sample. Okay, 3 different samples all together. So answer choice A says, oh guys, I don't even want to pronounce this, but I will. Isoguanine and purine were detected in both meteorite samples, but not in the soil sample. Okay, this is correct. Yes, Evander, it's correct. Anyone else? Elijah, it's correct. Let me see. Maria? Are you here, Maria? Maybe Mario? Camila, are you here? Sorry guys, I'm not trying to pick on Evander again, but I will, because I love Evander's explanations. I will, but I'm trying to. Aaron, are you here, Aaron? No? Nobody's here? Okay, Evander, looks like it's gonna have to be you.
So we're looking for something that supports the team's conclusion that the nucleobases, the things on the left side of the table formed in space and not on Earth. So if that were true, they would be things that are in the meteorite but are not in the soil, and isoguanine and purine are both in the meteorite in both the samples, but not in the soil. So that tracks with what the team's conclusion is. So that's why I believe the answer is A.
Okay, I wholeheartedly agree with what you just said, Evander. You are correct, okay? I also believe answer choice is A. Doesn't mean we're not gonna go over the rest, okay? Because, you know, maybe we skipped over something, maybe we just quickly glanced over something and we got it wrong. Sorry about that, troubled child. So we're gonna say that A is very likely to be the correct answer. So isoguanine and purine, they were detected. Okay, absolutely. They were detected in both of them. Okay, we're not just looking at one, we're looking at sample 1 and sample 2. They're detected. We see them. They're detected, small amounts, but detected nonetheless. Okay, and not in the soil sample. Both of them were not detected in the soil sample. This is supporting what the researchers concluded because, again, what did they conclude? They concluded that it actually formed in space and it wasn't a contamination on Earth. As we can see, if there was contamination on Earth, we would have detected these 2 nucleobases in the soil sample, okay? But since this is not the case and it's supporting the researcher's conclusion, there was no nucleobase detected in the soil sample, okay? So, yes, answer choice A, very, very likely to be the correct answer, but let's go to B. Adenine, xanthine were detected in both of the meteorite samples and in the soil sample. Who wants to give this one a go? Somebody? I have to give it a go. Back to be lonely.
I
Yeah,
would like to try.
oh, perfect, Carolina, please.
So again, with the little paragraph that we're given, clearly what you have underlined that says are not a result of a combination on Earth. That goes against that completely because they were both found in the meteorite and soil, but we're only looking for it being strictly like from space, not Earth at all. That's how I saw it.
Okay, I absolutely agree, okay? Sometimes College Board likes to trick us, okay? We like to get tricked by, not we like to get, they like to trick us with these answer choices. So that's why sometimes we see, okay, some answer choices are gonna be correct but not answer the prompt, or some answer choices are gonna answer the prompts but be incorrect, okay? We have to decipher what we're being asked and if the answer choice is right. It's kind of like a two-part thing, especially with these types of questions, okay? They always like to throw in a question that answers the prompt or answers the statement that we're supposed to conclude, but that the answer choice in and of itself is incorrect, okay? So with this one, we're looking at adenine and xanthine, okay? They were detected in both samples as well as in the soil samples. Absolutely, they were detected. So you might see this and be like, well, yeah, B is correct. It was detected. I can see that on the chart. Okay, B is the correct answer. No, okay? Remember, we have to use what we read, okay? There's no evidence that nucleobases in the Murchison meteorite formed in space and are not the result, there is evidence, sorry, that the nucleobases formed in space and are not the result of contamination, okay? So we can't say that they were both detected because this would completely contradict the conclusions that this team came to, okay? If the conclusion was right, the answer choice would have to say, like A, that nothing was found in the soil sample because there was no contamination on Earth, okay? B is the incorrect answer choice in this case. C, hypoxanthine and purine were detected in both the Murchison meteorite sample 2 and in the soil sample. What do we think? Just give me a no, I don't need an explanation. Just give me a no, yes, maybe. Sophia, you're saying no. Thank you, Sophia. Evander, Reina, thank you guys. So, absolutely not, okay? If we look at this, let's look at hypoxide and purine, okay? So it's telling us that it was detected in both the Murchison meteorite sample 2 and in the soil sample. Okay, so 1 second. So, okay, absolutely, they were detected in the sample 2, but what about sample 1? It was detected in sample 1, okay? So the question, the answer choice, it's lacking logic because it's detected in both, so why are we only gonna say it was detected in one? And again, purine was not detected in the soil sample. And it here says that it was detected in the soil sample. Oh, I'm sorry, wrong one. Okay, so C is incorrect, okay? The answer choice in and of itself is faulty, it's false, it's incorrect, okay? So we cannot say that that would be the answer choice to the question. Okay, remember, the answer choice has to be correct in its entirety and it has to answer the question, the prompt, whatever we're being asked. C is incorrect. And then D. Isoguanine and hypoxanthine were detected in the Murchison meteorite sample 1, but not in sample 2. Let me delete some of this, it looks very crowded, we might get confused. Okay. So, very quickly, we're saying that isovanine and hypoxanthine were detected in sample 1 only. Okay, but not in sample 2. That is absolutely incorrect. They were detected in both. Okay, detected in both. D is incorrect. There's not even a thought of that. That's one that you could automatically just take off, save some of your time. Okay? Answer choice would be A. Do we all understand? Do we need a little more reinforcement on A? This one, again, it's a tricky one. Guys, all the hard ones are, they're interesting to work with, but little by little, we got this. Would we good? I think we might have time for 1 to 2 more questions if we really speed it up, okay? So let's try for 2 questions, but we're just gonna, oh, sorry. So,
What's your name? 6 minutes.
let's take one.
So, like,
No? Oh, sorry, guys. Fuck. I'm not good with technology. Okay, it was A, perfect, that's cool. Okay, so we're gonna do this one very quickly.
we're gonna try and speed run this next one, so. This one is, okay, this one is, difficulty 3, so also hard, but it's gonna be pretty fine if you guys keep track of like the timeline, like over here, so. In 2006, I'm not even trying to be that name, the colleagues calculated the most accurate estimate yet of the average velocity in kilometers per second of the large, I'm not even trying to be that. Of a galaxy, before the 2006 study, estimates of the average velocity were low enough. So before the 2006 study, estimates were low enough for the LMC being this little thing over here, so this is the LMC. To maintain an orbit around the Milky Way galaxy, but according to an analysis by, I'm not even gonna read that either. The estimated velocity from the 2006 study is too high for the LMC to maintain such an orbit. So let's pause there. What is it saying? Anything before 2006 is viable, okay? So that means that this 1994 and this 1980, so the 334, the 344 and 297 are viable. However, this 2006 one is too high, alright? So this one we're gonna kind of keep that in mind, it's way too high. Therefore, if Bessel and colleagues are correct, the maximum average velocity, so we're looking for a maximum range, right? For the LMC that would allow it to maintain an orbit, so this is important. If the 2006 one is too high to maintain an orbit, then that means that we can't really take this into account, okay? We can't really use that in our range, or at least not as much, like we can't go at that point or beyond. Because it's too high, so we're looking for something below that, something between some number and that, but we can't go above that. And then it's likely blank, so again, we're looking for either a range or above, below, as long as it's under that, but we're looking for some kind of good gauge for the maximum average velocity, okay? So let's look at A. Above 344, but below 378 kilometers per second. How do we feel about it? I'm seeing no from Sahara. I'm seeing no from Zabdiel. Can anyone tell me why you don't think it's A? No, yes, no. I just kinda wanna see where you guys are at. Actually, no, we're speedrunning anyways, so it's okay, I'll revisit it. Okay, B, above 297 but below 344. Yes, I'm seeing a lot of yeses here, okay? Does anyone think it's above 378?
Yeah, pay attention, maybe you're not.
No, okay, so we can immediately eliminate that one. That one was, the responses were faster for that one, so I'm gonna immediately exit out. Below 297. I'm seeing, okay, it's more notes. So right off the bat, C and D are wrong. However, I wanna point out that the answer for this one is A. And the reason that I'm gonna point that out as our kind of like oddball answer that you guys might not have expected is because we're looking here for the maximum average velocity, right? We know that this number is accurate. like we know for a fact that number is accurate, right? Why? Because anything like before 2006 is pretty accurate, right? We also know that 344 is a good number for us, right? Because 344 is also before 2006, so that means it's pretty accurate, right? What does this mean? 378 is too high. But anything below 378 would be a valid answer, right? Especially because we're seeing that 344 and 378 are pretty close. So we're looking for the highest number. This 297 is good, but it's a little too low and it doesn't make the best use of our data. Because our data is saying it just can't go above this. It can't go above 378. But below, give me one quick second. Hold on, guys, I'll have to check the chart. So I guess the negative. But anyways. Alright, it doesn't make the best use of our data. Why? Because we're looking for a maximum average velocity. 297 we know is correct, but we're seeing it's way below these other answer choices. So we also see the second part. Guys, we went over this before, right? We want to look at both parts of the answer choices. Right after this but, we see below 344. It does not have to be below 344 because we know that this came before 2006, meaning 344 is a good number because it tells us here that it's that it's before 2006. So anything before that is pretty good, right? So this means that, let me just clear this for like clarity's sake. This means that this is valid. So this second part is what makes that answer wrong. And this makes it not a good range. Then C and D you guys eliminated right off the bat, and that's why our answer is A. That one I want to show you guys because the actual interpretation of the question isn't necessarily hard. It's just kind of keeping track of the timeline and like making the best use of the data, as opposed to like this first part would have been right, but that second part would have been wrong, right? So sorry, that one's backwards. And there we go, it's the answer there. Guys, we already know.
Alright, guys, I hope you guys enjoyed the reading section of today's stream. So we're gonna go over and transition over to the math room. You guys stay right there, I'll have them leave and then we'll join like the main Zoom room and then we'll get started with math for the day, alright? I'll be back in just a second.
No. Please.
Is he gonna like bring them over here or?
Can you, please?
Guys, Fabiani's a little lost right now, but okay.
Hello, can you guys hear me? You guys hear me?
Yes, we can.
Okay. Well,
You're kind of bad, Fabio.
Can you
Yeah.
speak up a little bit, buddy?
hold on, let's see. I'm yelling, but I don't know. Let's see.
Maybe yell-
Worse. Better or worse?
The same.
No. What about this one? Better or worse?
The same.
Chat, come on, let me know. Better or worse? Yeah, the audio. Can you guys hear me better or worse? Not at all. I'm leaning towards not at all.
Yeah.
Hi, better or worse?
Let's.
Hello?
It's your computer.
Can you hear me better or worse now or not at all? Evander, can you hear me?
It's just kind of like.
Do you hear me good or muffled?
No, you're good, you're good. You're okay.
Awesome, beautiful. Alright.
I don't teach, I just say you. I'm pretty.
Not where you're.
Okay, so
I did an aperture.
unfortunately, the room we're in today, like, the camera does not work, so you guys are gonna have to like,
Yeah.
not see me.
Wait, but we haven't used this camera.
Yeah, I know, but this is one of the rooms that the camera's broken, but, so you guys won't be able to see me, but I'm here and I'm definitely seeing you guys. So do not worry.
Yeah, sorry about that, guys.
Alright, so,
Make sure to turn on the screen share.
yes, for sure. Let me kick these bozos out like the other one. Let's see.
I mean, we could just tell them to take it off Zoom.
Yeah, you can tell them to go.
Or, but make sure you're recording.
Yeah, we're still recording, at least we should be.
Oh, yeah, because it's recording the whole.
Okay, let me share my screen. Breakout room. Okay. Oh, wow.
Love you, honey.
Yeah, like, you're only teaching them.
So we have here.
Bye, Bruce.
I use Zoom.
Yeah.
Can you guys see my screen on Zoom? Are you guys able to see my screen? Can I get a thumbs up? Awesome. Alright, so today's set of problems is gonna be like kind of the book we're gonna be using from now till the end of the course. So I got this book. Oh, let's see what one. Just a second, technical difficulties. There you go. Alright. I got this book. So I got this book when I was studying for the SAT, and I found it to be really effective, like I was saying at the beginning, in giving us pretty difficult problems, but like honestly, the problems, although they are difficult, you're gonna see the patterns just kind of start forming, and it's going to make the math section a lot easier, I would say, because again, you're getting exposed to the hardest difficulty questions on the entire test. So right now, what I'm gonna have to do, I'm gonna have Tony, he's gonna go into the chat and drop the PDF of the book. So
Do I join on my laptop?
yeah, that's fine. For those of you that are on Google Classroom, the file is on Google Classroom already. So on that front, you guys should have the book already. It's called 63 SAT Math Tips. For those of you that do not have Google Classroom, Tony is dropping it right now.
Wait, it might kick you out. I'll sign in with mine.
Okay. Tony's about to drop it, so you guys can kind of follow along. That'll be what we'll be using for the next couple of weeks.
Yeah.
Hold on, try to get full screen so I can see you guys.
And that's also a resource that you guys will be able to use, of course. If you miss like a session or anything that we will be discussing, you could always go back to the tips yourself. So
Yeah, and this is a great book, like, and we also have practice tests, we'll make those available at some point. Our goal here is try to get through everything. We might like, so it's 63 tips. There's low-key some stuff that we're gonna skip because it's like low-key not tested as much on the test, and it's like a waste of time to learn it in a certain way. But most of the stuff in on there is really, really useful. Alright, so alright, we're gonna get started with question number 1. So does not work. Just a sec. Okay. And let me make sure that I can annotate with the Zoom screen so you guys can see everything. Okay, so the first part is sort of a review of everything we've been doing up to this point. So up to this point, we've really been focusing on slopes of lines, equations, and getting comfortable with the way that graphs work. So
okay, I joined.
and understanding, yeah, and then just like drop it in the chat.
Wait, who needs to approve me?
Approve for what?
Is that I need to be admitted.
Okay,
Is it
hold on,
you?
I'll do that. Oh. Okay, so Tony's about to drop the book in the chat for you guys, but what we've been focusing on is linear equations, functions, slopes, things like that. So you guys are comfortable with kind of the elementary portions of the SAT. Now we're going to use all that stuff and then more with these practice sets. Some of these problems should feel very similar to what you've done in the last possible days. So let's get started by taking a look at the at this problem set. So let's start with number one. So number one says, for a linear function f of 0 equals 2 and f of 3 equals 5. If k equals f of 5, then what is k? So a couple of things here. I want you first, guys, I'll give you guys like 30 seconds to like kind of think through. What would you do in this situation? What strategy could you use to like solve this, and what information do you have? What are they asking you for, and how can you use what you have to get what they're asking for? All right, Elijah.
You could divide 5 by 3 to get the slope, and then multiply the slope by 5. I'm not sure.
If it started at 0, 0.
Oh, wait.
If it started
Oh,
at 0, yeah, you could do that.
yeah.
In this
So you
case,
would.
I like what you're thinking about slope, so you're on the right track. So for those of you that remember like the time that we did functions, this is the perfect example for you to use the table trick, right? Do you guys remember how to pull up the table, right? You type in table into the
It has to be
calculator.
lowercase.
Lowercase. Oops, sorry guys. Table. You plug in table and the table's gonna pop up. Or I found this out today, I actually didn't know this. If you press the plus button, you can also click table and it'll do it automatically for you, right? So what we want here is okay, first let's like establish what they're asking us. So they're telling us that k is equal to f of 5, and we want to know what k is. So in terms of actual functions and things like that, what is it really that we want to find? The value of what?
The y value when x is 5.
Thank you, exactly. The y value when x is 5. So like this thing right here, it looks like a little like, okay, it looks a little confusing. Like they could throw you a k in there for no reason, but all this k is telling you is like, we just want to know what f of 5 is. Like, because k is equal to f of 5, they're interchangeable. You're just looking for f of 5. So now we just have to identify what are points that we are given, right? Could someone tell me what are the 2 points that are given that we can now plug into this table to then find the equation of the line and be able to find what f of 5 is? And let me open up the chat as well, because sometimes I know the chat. 0, 2, and 3, 5. Awesome. So we plug in again 0, 2. We plug in 3, 5. It's going to automatically populate once we click the add the regression button, and it gives you this equation of the line, right? So we're given the equation of the line. So like we established earlier, we're looking for the value of y when x is 5. So what would be the answer in this situation? C, right? F is 5. I think it's like right here.
There's any answers in the chat.
Yeah.
Oh.
When f is 5, we see that is 7, right? So a lot of these problems, I would say, the hardest part about problems like this, for example, is just being able to identify what can be used as a point, right? And start thinking about in terms like when you see a function or they give you a situation, how can I turn this into points that I can like plug into the table, right? For example, like we talked about this like when we did like functions a while back, that if they give you something in terms of time, right? Time 0 is like when you started, right? So it's all about being able to like get the points. And we're gonna see other examples where it's literally all you need to do is find the 2 points, plug it into the table, and your answer is gonna be right there waiting for you. All right, is everyone good with this problem? Awesome. moving on. The table above shows some values for the function f. If f is a linear function, what is the value of a plus b? All right. Here, it's gonna require us to think outside the box a little bit. Does anyone have any theories as to how we can solve this? Evander.
So in a linear function, if we go back by 1 in x, we subtract the slope. Let's call the slope k. Can I annotate?
Yeah, you can annotate, go ahead.
Okay, so let's call the slope k. So then a is now, I'm gonna type because honestly, drawing this all out on MacBook. So this becomes 12 minus k. Because we're going backwards, we minus 1 of the slope. Then for b, that would be 12 plus k. We added 1 of the slope is k. So then a plus b becomes 12 minus k plus 12 plus k. The k's cancel out to give us our answer of 24, and it doesn't matter what the slope is.
Yeah.
Good job. So like, basically what we see with that is because of how the slopes, this like you're basically you're taking away 1 from the slope from the 12 and you're adding 1 from the slope from the 12. Ultimately, it's not going to matter. So the answer is 24, and that's one way to get the answer. The way the book wants you to do it, it's basically the same thing, but you're doing it in a different way. Basically, you're working on your assumption. Okay, something really, really important about linear lines and slopes. You always have to think that like because the slopes of a linear line are constant, meaning like the slope will never it of course is changing, but it's always going to be changing at the same rate. That means that if you take the slope between one point of the function, it's going to be the same slope as another point in the function, right? So in this case, the way you can look at this is saying, well, look at this. 0, if you take the slope of these two, it should be the same slope as these two, right? So because the slope of a linear function is constant, then the slope between the 2 points are going to be the same. So in this case, we could take the slope for, let's call this 1, we'll call this 2. Slope 1, we could do 12 minus a over 1 minus 0. Sorry, well, that will be number 2, is equal to the other one. So we could do b minus 2 over 2 minus 1, right? So now what we have on our hands is just a simple equation, because this part on the bottom we already know is the same. We know that 1 minus 0 is equal to 2 minus 1. That is factually true. 1 is equal to 1. So we can kind of ignore this for now and just focus on this, right? Remember, what they're looking for us to do is find the value of a plus b. So now all we can do now is look at this. 12 minus a is equal to b minus 1. And all we would need to do now is go through and hold on. Is it b minus 12? Hold on, I did 12 minus a.
Yeah, it's b minus 12.
Right, b minus 12. Okay, awesome. Okay, so now what we need to do is just rearrange so we only get a plus b on one side, which is what we wanted, right? So to do that, we get 12 plus 12 is equal. So we bring the negative 12 to the other side, and then we bring the negative a. We add a, so we get a plus b. And that's how we get a plus b is equal to 24, right? So what I'll say about this, there's problems like this where if they ask you to solve for something weird like 3a or like 5a plus b, sometimes it's not even going to be necessary at all to find what a and b are individually for you to solve the problem. Because like sometimes by just simplifying whatever they gave you in the situation, you'll be able to find the a plus b without even like, we don't really care about, we're not interested in what a and b are. we wanna know what A plus B are, so sometimes you can go straight and just like, get straight to the answer of like whatever they asked you for, which in this case was A plus B, alright? Does that make sense for everyone? Or does someone need like more clarification on something? We're good? Awesome. Moving on. Okay, something like this. A linear function is given by ax plus by plus c equals 0, and then they give us a bunch of stipulations. A is greater than 0, b is less than 0, and c is greater than 0. Which of the following graph best represents the function, right? So does anyone have an idea of maybe something we could do? Evander?
We can plug in the simplest possible numbers for A and B and C. For example, for A, 1 is greater than 0. Great, A equals 1 now. B, -1 is less than 0. Great, B equals -1 now. C, 1 is greater than 0. Now C is 1. So we get x minus y plus 1. And then you convert that to the usual y equals da 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 da, and you get your answer.
Right, so on Desmos, I would say, so like that kind of like, this is what I would say is a perfect example of a question where plugging and chugging is a great option, right? So look at this for example, on Desmos, whenever you see something that gives you like a bunch of weird variables like ax plus by plus c, and then it gives you like all these like a is greater than 0, b is less than this. I would always just plug in the equation exactly as it appears, and then use this tool that allows you to add a slider. Then you can manipulate the variables and then, you know, plug in the things as needed, right? So, like Evander said, we should be trying to test the conditions. Now, the thing with linear equations is that there's only 4 possible options of what your line could look like. I guess, like, you either can have a positive line with a positive positive slope with a positive y-intercept. You could have a positive slope with a negative y-intercept. You can have a negative slope with a positive y-intercept, and then a negative slope with a negative y-intercept, right? So there's only 4 possible combinations. So once we actually plug in the values for this, we're going to be seeing on the graph the function that graph, like whose graph most directly matches like the circumstances. And notice how the graph has no like actual numbers, it has nothing. It's just basically telling you positive, negative, right? So let's try that out. So A is positive, right? So we can leave it at 1. B is negative, so let's make that a number less than 0, so -1. And C is positive, so we can leave it at 1, right? So which graph matches to the one that we see there?
B
You said
or D?
D, right? D is the one that matches because we see, well, it has a positive slope and a positive y-intercept. And we see this as a positive slope and a positive y-intercept, right? So usually I would say for things like this, it's always best to like graph it and then try to use the slider to like make the conditions true, right? With these type of problems, it's also good to remember that like low key, you can make up like any of the numbers that you want. Like if we used, now it would be a lot harder to see because you wouldn't be able to see it that well, but like you could use literally any number that fits the condition is going to make this true. So always don't be afraid of like playing around, plugging and chugging for stuff like this, right? Because I would honestly, if you like told me this like straight off the bat, I would be like, oh, I don't know. I would have to like log into the calculator and then visualize it with like the situation to be able to answer it, right? All right, does that make sense for everyone? Awesome. I want you guys to try number 4. It's very similar to what we did before with the table method. Alright. So can someone tell me what we should do to solve number 4? Let me open up the chat and see. Okay, D -4. So you plug in the 3, 2 and the 5, 6 in the table. Awesome. So we got our table. We get 3, 2 and 5, 6. We press the button right here, it gives us the graph. And then here you could either look right here at the point at where it intersects the y axis, where you see the 0 right there, or you guys can look at the equation right here and see that your b is -4. That'll also solve the problem for you. Awesome. All right, number 5. Same thing, same method. C, awesome. So here again, same thing. We find the 2 points that we can plug in. So in this case, you have 3, -2. And we have 4, -4. And then we find our x-intercept, which is right here. Be like right here. Which would be 2. Right there. So again, with a lot of these methods, like, and you're gonna see this when like we get to word problems later on. The most important part is being able to pick out what points you can plug in and then plug them to the function. All right, here, number 6. The thinking is very similar to something we did earlier with thinking about how the slopes relate to each other, right? How the slope at one point in the line is the same as the slope between any other 2 points on the line, right? So I'll give you guys like a minute to try this out, and then I'll ask for one of you to share. Alright, do we got it or do we need help? Help, okay, awesome. Alright. So, rule number one of a line, right, is that the slope between any 2 points on the line, if the line is linear, is going to be the same slope as any other point on the graph, right? So, for example, if we took the slope between this point right here and this point, it's going to be the same slope as if we took it from this point to this point, or this point to this point, right? Because the rate of changes are ultimately the same, right? So we have to use that to our advantage, right? They give us two things here that are kind of weird. First, they gave us two variables here, and then they gave us like something to plug in there. So we have to use information that we have about the line to then be able to go in and try to tackle it. So the first thing I would do just to make our lives easier is look at this. B is equal to 2a, right? So if they're telling us B is equal to 2a, how can we rewrite that point a comma b to make it just in one variable? Because again, having things in just one variable is going to help us in being able to create a regular linear equation. So how could we retype that in? A comma 2a, awesome, love it. A comma 2a. Right? So now we have to think about the slope and how we can take the slope. So we have two full points. So what's the first slope we can take? What 2 points can we use to get an actual number slope? Awesome, 0 comma 3 and 5 comma 0. So we can go on to Desmos or we could do it by hand. I would just always recommend using Desmos just to like make sure that like you eliminate the possibility of maybe a human error because that always happens. And then you just plug it in 0 comma 3, 5 comma 0. And then we use the linear regression tool. And we find that our slope is negative 0.6 x. So that's negative 0.6 x, which is the same thing as negative 3 over 5x. So you guys got how we got to the slope, right? Okay, we found what the slope of the entire line is. So because of the way that like slopes and linear equations work, we're like the rate of change is constant, right? It has a rate of change, it's changing at a certain rate, but it's a constant rate of change, right? It's not like an exponential function or a quadratic function that the rate of change is different at a different point. So now we can just take the slope between, we can choose a point 0 comma 3 or 5 comma 0 and take the slope with the a and the 2a and make it equal to this and make an equation. So what do I mean by that? We start, for example, let's do 2a minus 3. All right, let's use these 2 points. 2a minus 3 over a minus 0 is equal to what? Is equal to negative 0.6. Awesome. Right? So again, let me explain where we got all of that information. So again, it goes back to the slope being the same for between any 2 points on the line. So we already found the original slope using the actual numbers that we have. Now we can just retake the slope with the variables. As it's all in one variable, it just becomes an equation, right? So we set up the 2a minus 3 over a minus 0 is equal to our slope, negative 0.6, and then we just have to solve for a. Because that's what they're asking us here. So what's your answer? C, that is correct. So again, when it comes to these problems, by the way, and again, let me preface this by saying these are going to be, I think, the hardest versions of the problems that you're going to get, right? But if you get comfortable with saying, okay, knowing how the slope works and being able to now apply it in like 2 or 3 step scenarios, that means not only are going to go to like the problems that are going to require you to just do one of those things, but then when you get to the hard module of the test, this is the type of problem that like they love putting on there. And I actually remember them asking a question just like this on the test. So the reason it's C is we go in to here. Hold on, give me a second. The calculator and we plug in the equation. 2x minus 3. Two x minus 3 over a minus 0. Sorry, x minus 0 is equal to negative 0.6. And this is our answer. Let's just put a random like y value there so we can like find the intersection quite a lot easier. We see it's like 1.16. 1.16. That would be the number that most closely approximates to it, 15 over 13. So does that make sense? Awesome. All right. This is a tough problem, but again, I hope that it's helping you guys like start like thinking about the slopes in a different way and start getting more used to like the higher level difficulty. All right, moving on. Something like this should be pretty easy. I'll have you guys do that and tell me what it is in the chat. B, right? And then how did we get to B? Right. Plug in the points on the table onto the table, and then it will give you the function basically. Does that make sense for everyone? Yes. He should be in already. I let him in. And the other thing again with the SAT is that the questions are going to be pretty rinse and repeat. After you've done enough practice, you're gonna notice the question types are just like the same. Like, look how many questions you've done that have literally been just like, look at the points, plug them as your graph, and then see what the answer is, right? All right. Number 8, right here. Let's do 8 together, and then I want you guys to try number 9. Okay, number 8. So they're basically asking us if we increase one variable by this much, how much is the other variable going to increase by, right? So does anyone have any idea of what would be kind of a fast way to solve this? Okay, make a table with the information and make C equal 0. We could try that. I would say the best way to do this is kind of just plug and chug it. So like, look at it like this. So like, they tell us that F, they give us this formula, right? We're looking for an increase in 27 in the Fahrenheit, right? So I would say exactly. So I would plug in like I would plug in 0 first for Fahrenheit, see what my Celsius is, and then see what the difference is when we plug in 27 for Fahrenheit, see what our Celsius is, and then find the difference, right? That would be exactly, well, 32 and 59. Would that be 27 difference? Yeah. You could do 32 and 59. You could do any combination of two like you could plug in any number for Fahrenheit, any two numbers for Fahrenheit that would be 27 away from each other. And then the difference in the Celsius, of course, is going to be the same. So in this case, let's just use the numbers, let's just use 0 and 27. Just where's the ball? Trying to find my mouse. Well, there it is. Okay. So 0 is equal, so that's like, let's plug in 0 for F. Is equal to 9 over 5. Is equal to 9 over 5. 9 over 5 Celsius. So we can replace the Celsius with an X. So decimals will recognize it, plus 32, right? So then our second one would be 27 Fahrenheit, right? Because we're increasing by 27 is equal to 9 over 5x. X plus 32. All right. And then we go out here. And we can see what the difference between the two are, right? So here we see negative 17.7, and here we see negative 2.7, right? So what's the difference in Fahrenheit? Or the difference in Celsius for that increase in Fahrenheit? -2, and so yeah, it would be 15, right? So again, this is a great example of a problem where I think plugging and chugging is going to be real quick, right? You just find the two numbers that like would make the situation make sense and use the calculator to your convenience, right? So the answer would be 15. Does that make sense? All right. Using the same methodology, I want you guys to try out number 9. Okay, how did I get 15? So we plug in the different values of f, so 0 and 27, and we look at the values of x, right? So the values of x are 15 away from each other, right? It goes from -17 to -2, right? So when we increased the Fahrenheit by 27 degrees, our Celsius increased by 15 degrees. Does that make sense? Awesome. All right. Same methodology here. Okay, Evander, you got B. How did we get B?
I I wanted to answer number 10 because I like number 10, but I actually did this on paper because I'm too lazy to pull up Desmos. So it's the same thing as the previous problem, except instead of plugging in 0, I plugged in 60 and then 95 for P, because if you plug in 60 for P, K equals 0, so then the increase in it is literally just what happens when P equals 95.
Good. So again, same thing, you pick two numbers, you would plug them into the, like, pick two numbers that like would make the the situation they tell you is true, so you could pick 0 and 60. What I understand is really smart, because then you basically can forget about K for the first one and just find what the difference is for 90. But when it comes to these problems, again, it's all about plugging and chugging, right? And using the situation to your advantage, right? Does that make sense for everyone? Okay. This next problem right here. Oh, sorry. Okay. Do you guys remember, like, in elementary school when you would do the problems, like these like geometry problems that were like, they would give you like an odd shape like this, and they would have you find the area, like they would tell you this is 10, this is 6. No, that's too much. Or like they'll tell you like this is 10, this is 6, this is 3 and 3, and this is like 5. So then you have to like go ahead and solve like the, like, find the areas and stuff. Like the way you would do that is that you would say like, okay, if this is 10 up here and this is 3 and 3, then this has to be 4. Like you would have to like build and fill up the puzzle pieces before you could solve the problem, right? The problem they give us like now is just like this. There's multiple parts of the puzzle that you have to like build up with information that you're given to be then able to find the information that you need to actually solve the problem. So let's start with reading the problem that they give us. So they say there is a line tangent to the line. So this line L right here is tangent to the circle. That means it touches the circle at exactly 1 point, right? And that point we call it 8, t. Pretty importantly, they tell us the radius of the circle is 5, and we want to know what the vertical distance is between the x-axis and the point where the point is centered, right? So with radiuses, the interesting part is if you draw from the radius to any point outside of the circle, it's going to be 5. That's 5. That's 5. That's 5. This here is 5. That here is 5, right? So something important about circles that you guys should know is from any point, like from the center to the edge of the circle, that is going to be the radius, like a straight line out. So we have to use that information to now build up a way that we can like build up stepping stones to find what the vertical distance is, right? So here's the first part. First part being, let's draw the center of the circle right here. So from here to here, what's the distance? Five, right? So this right here is 5. Okay, what's the distance from here to here? 5. Awesome. Right? Now I want to use some context clues of things we already have, right? We know that from here, from this point right here, all the way here, that's worth 8, right? So we know that how much is it from here to here? 5, right? There's a lot of 5s in here. If from here to here is 5, but from here to here is 8, then how much is this portion right here? 3, right? Now we can draw a line right here and think about this as a right triangle. So if that is 5 and that is 3, then what is the missing portion that we need to solve? it's 4, right? This comes from, I think the easiest way to remember this is just remember when it comes to right triangles, the numbers 3, 4, and 5 and its multiples. Those are what you call a Pythagorean theorem. So like always, the whole numbers 3, 4, and 5 and their multiples are going to give you a perfect right triangle. In this case, we know that we have the 3 and the 5, we're missing the 4. So, or you could just do the Pythagorean theorem. 5 squared is equal to x squared plus 3 squared. Then you would say, well, 25 is equal to x squared plus 9, then 16 is equal to x squared. Take the square root, 16. You would find that's 4, right? So that's how you get 4. So now the question is, how much is it from the bottom of the x-axis all the way to the top? Now that we have all the pieces, we're able to solve. So the answer is 9. And you get 9 from saying, well, this height from this height to the center of the circle, which is the same height as right here. If that's 4, and then from here to here is 4, 5 plus 4 is equal to 9. So this problem is just like a lot of like, you would definitely have to, it's like that example of that problem I gave you earlier where you have to like break everything down, every piece of information you have and use it to your advantage and like play around with the drawings and stuff for you to find the answer. This is, and I would say the hard thing about this problem is how it intersects geometry and like algebra. Because it has some Pythagorean theorem involved, it has like some knowledge about circles involved, it has the knowledge about the tangent lines involved. So it's definitely a hard problem, but does everyone understand how like that problem worked? Or does anyone need any more clarification? It makes sense. Awesome. Let's move on to the next portion. Let's see. I'll skip 11 for now because that's very similar to what we've been doing. 12 is very similar. A lot of these are very similar. Now I'm gonna pass it off to Tony so we do something different for a little bit because again, you're gonna see that after a while the problems are gonna be pretty rinse and repeat, and you should be able to do all of them pretty perfect, right? I'm gonna pass it off to Tony who's gonna do some rate of change problems. And again, with this 63 tip book, you guys can also like I might actually end up posting like the whole practice test for this that you guys can do like for extra practice and stuff. It's gonna take us a while to get like further into the book, although the as you guys can see, because you guys have the book, it's not a lot of the sections aren't as long as this last one. Now again, the linear functions and linear equation part of the book is super long because it's such a fundamental part of the entire test. So by the way, can you guys drop in the chat what you guys found the hardest things to be on the math section practice test that you took last time?
It can be like the practice test 6 that we did last week, or just any SAT you've done. So getting a lot of geometry. Oh. Yeah, usually the last like 2 to 3 questions are either like
Diabolically hard.
ridiculously hard.
I would say though that like I've seen like out of all the practice test material that I've seen, this book that we're using now is what best prepares you for those like last 2 or 3 questions. Because again,
These are definitely the harder ones.
again, like when we go back, we'll probably do another practice test like of the regular ones at some point. We'll go back to that, and you guys are gonna be like, wow, like honestly, the SAT is pretty easy because these problems are really, really hard. All right, Tony, take it away.
Alright. So we just did a lot of general linear functions, but now this is gonna be more going in specific to slope and rate of change, right? Because rate of change isn't specifically solely for lines, right? And that's what we're learning here. Going to emphasize the textbook in this part. We will still be using decimals. So here on the top, always just for this book in specific, I want you guys to keep in mind whenever you use it on the top, there's going to be like an actual quote unquote tip where it actually kind of teaches you about the content. So if you guys like have never learned this stuff, you're still getting like the information, right? And you can study this, like you need to. So here it's talking first about constant rate of change, right? And for constant rate of change, it's only talking about a line, right? So the only function that this is talking about is about a line, right? And it says any line or linear equation will have one slope and it will always stay the same, right? So for this one line, it's going to have the same slope throughout the line, the same constant rate of change. So same constant rate of change. Regardless of which 2 points are used, right? So the either of the points that I use to calculate the slope on a line, it will give me the same slope, right? So it's emphasizing a line has the same slope on all its points, right? Then it has average rate of change, right? So average rate of change is something that exists between 2 points, right? Because it's quantifying the change in the function, right? But what it's doing is it's saying how much is a function changing in between 2 points, but it's using the x value as a reference, right? So how much of y changes every time you increase by 1 of x. But basically, average rate of change, it's like it's drawing a line between 2 random points on a function, and it's taking the slope of that line. And that's what average rate of change is, right? And it's gonna take that same format, right? Here, you can't actually do it on any 2 points, right? So average rate of change, it's just a formula you use between 2 different points on a function. And what it's modeling is the rate of change of a line if there was a line between those 2 points, right? So we're gonna see more how we could literally just use the formula here on the bottom. So I'm gonna use decimals for these with the calculator. Let me reload. Oh. Oh, here, yeah. So rate of change, average rate of change, we know it's this formula, right? Y2 minus y1. So it gives us this function, right? This isn't a linear function, it's a quadratic. So we know that this doesn't have a slope. We can take the average rate of change between 2 points, but there's no slope. And then it's gonna ask us what the average rate of change is of that function as it changes from 0 to 4. What it's asking us to do, we have to find the points when x equals 0 and x equals 4, and then take the average rate of change between those 2 points. So what we want to do first is find f of 0 and f of 4. So f of 0, the writing is not that good, I'm sorry, but f of 0, we plug in 0, 1/2, 0 minus 4, right? 1/2 times 0 is just 0, so f of 0 is going to be -4. Wow, so now I can write down what that point is. So it's going to be 0, -4. Now I'm going to try to find the other point. So now I'm going to try to find f of 4. So f of 4, and now I have to plug in 4 to this function, right? So 1/2 4 squared minus 4, and now I'm going to simplify, right? So 4 squared is 16, so 1/2 of 16 minus 4, so it's 8 minus 4, which is just going to end up being 4, right? So that's another point, 4, 4. So we found 2 points, right? By plugging in x to the function, we found 2 random points. Now we can actually find the slope. So, yeah, we can use Desmos for the slope, it's just a fraction. So it's gonna be here. So we just put, just a tip for you guys, if you put a slash, it puts in a fraction with nothing in it. Alright, so as you can see there, it puts a fraction, and then I'm just going to do y2 minus y1. So 4 minus -4, which is just gonna end up being 4 plus 4. Divided by 4 minus 0. Right? Just to help you guys understand, I can write this here. This is gonna be x1, this is gonna be y1. This is gonna be x2 and y2. So then you can kind of see clear, y2 minus y1 is 4 minus -4. So 4 plus 4, x2 minus x1 is 4 minus 0. So then it's gonna give us that answer is 2, right? So at the end, we're able to get that expression is going to be equal to 2. And then you can kind of visualize that if you want, as literally just 2 random points on the parabola. So it would literally be going this, right? And 2 random points on the parabola, and I connect them. And 2 will be the slope of the line that connects them. So that's kind of a way you can think of it. Now 2 is kind of asking the same thing. It says, if an object is dropped from a cliff, then the distance in meters it has fallen after t seconds is given by the function d of t equals 4.9 t squared. So it's saying, I'm dropping an object from a cliff. The distance, like how far it is from the cliff, I'm gonna put that in a function, that's gonna be the y value. And what I'm gonna measure it by is how much time has passed. Right? So that's gonna take this relationship and it's gonna be shown by that function, 4.9 t squared. Now it's asking us, what is its average speed? And then this gives us a little hint here. It's average rate of change. So it tells us we need to take the average rate of change with those 2 points. First we have to find it. So first we're gonna find d of 1. Right? We plug in 1, that's just gonna be 4.9 times 1. So that's gonna be equal to 4.9. That's 1 comma 4.9. So now d of 3, that's a bit more complicated, I'll use decimals. So d of 3, so 4.9 times 3 squared. Alright, 4.9 times 3 squared is 44.1. So I'll go ahead and write that down here. 3 comma 44. So now I'm gonna do the same thing again and actually calculate the slope, right? That's all it's asking us to do at the end, okay? So I'm gonna put the fraction again, 44.1 minus 4.9, so y2 minus y1, minus 3 minus 1, or over 3 minus 1. And here we see that final answer is gonna be 19.6. And meters per second represents that it's going to be a rate of change, right? Because it's showing that every additional second, if there was a line drawn between those 2 points on the parabola, right? For this line, every new second, it goes up by 19.6 meters. So it kind of just helps you visualize that line, maybe its steepness. We'll move on to 3. I think 3 had a graph for 3 and 4. Yeah. So this kind of just has a graph here, right? And what it says is a flower plant is measured every day t. The height h of t inches of the plant can be modeled by a function shown in the graph and table above. So what it's saying is that every day that it grows, it's giving you the height of the rows, right? So it's telling you the height every day. And there's also a chart which tells you the height for every 10 days. So now it's asking us to find the average rate of change in height from 10 to 70 days. What I'm going to do, I'm gonna circle both the points, 10 days, and make sure T is 10, 70 days, T is 70. Now I'm gonna do y2 minus y1, x2 minus x1, right? Just find that slope again. So. Yeah, annotate. So it's gonna be 39.2. Minus 3.5. Over 70 minus 10. And there that's going to be 0.595. So our answer here will be 0.595, and just a little bonus to find the unit. The unit is always going to be days, or the x unit divided by the y unit. So we're no, I'm sorry, other way around. Yeah, it's gonna be the y value divided by the x value. So here it will be 0.595 inches per day. Because you kind of visualize that if you put a line between those 2 points, 10 and 70, it will be kind of not that steep, right? It will be have a not that big of a slope, it will be 0.595. And then the slope would actually be inches per day, right? Because it's going up 0.5 of an inch every new day. So kind of helps visualize that. But now we're gonna do question 4. Now it's asking us more about the shape, right? So yeah. Now it's asking us which interval is more steeper. So the word steep, or I'm sorry, greater average rate of change, right? So when you think a greater slope, you want to think steeper, right? So I usually remember 3 different slopes to just remember like what direction is increasing, right? So remember, the line that's horizontal, just like this, has a slope of 0, right? I remember perfectly like this line is y equals x, so that has a slope of 1. Then a super vertical one has a slope of infinity, right? So we went from 0 to 1 to infinity, right? So then here, after 1 is when you're getting like higher and you're approaching infinity, so you're increasing, right? So kind of anything going like this, right, will have a very high slope. So, and then when those that are going like this are gonna have less of a slope. So I'm going to do that, or I'm going to kind of analyze each of the intervals, right? To see which one has the biggest slope. Let's say which one has the greatest average rate of change. So what I'm gonna make a slope for each one of them. And then we're gonna see which one is, has a greater slope, right? So from 10 to 20, or yeah, 10 to 20, not that high, right? I'm just connecting the 2 points, right? This one, it's pretty high, right? This one gets a little less now because it's curving to the right. So I would still say 20 to 30 would be higher than 30 to 40. Because you can see it's kind of like starting to bend over here. Then it gets even steeper. So here, I would say that because it's just fully increasing the entire time, 20 to 30 is kind of the steepest one. So it has the greatest average rate of change there. This one is kind of just more based off shape. So does anyone have questions about this one in specific? This one can be a bit harder. Or are we good? I think we should. I don't know if there's any more questions for this topic. No. So I guess we'll be done now with rate of change. Does anyone have any questions about rate of change? Basically, the main idea you want to take here is when you're taking the average rate of change between 2 points, it's the same thing as if you were to have drawn a line between them and you're finding that slope. So that's kind of the main thing you have to think there. But here, we won't do number 3 because 3 was. Oh wait, no, yeah, we can do parallel. I thought it was tip 4. I'm sorry. So we can do parallel perpendicular lines, right? So there's just basically 2 main ideas when you're doing this. So 2 lines, if they are parallel, then they never touch and they have the same slope, right? So 2 lines are parallel, that means they have the same slope. So if line if there's a line y equals x, and I know that there's a different line somewhere and it has the same slope, I know the slope's gonna be 1 because y equals x has a slope of 1. The slope of the new line is gonna be equal because it's parallel, so it's gonna be 1. Right? Perpendicular, on the other hand, is not the same. If you have one line that's if you know the slope of one line, and you know that another line is perpendicular to it, then the slope of the new line is gonna be the negative reciprocal of the line you know, or the slope of the line you know. So the slope of a line that's perpendicular to another line is the negative reciprocal of the slope, right? And it goes both ways around, right? M1 is -1 over M2, M2 is -1 over M1. So that's the negative reciprocal, right? And where M is signifying slope here. Also, another thing to another worthy thing to mention is that if you multiply both of the slopes, like a pair of perpendicular lines, if you multiply both of their slopes, it's going to be -1. So just in case like they give you something like that, it's important to know. So here it says, which of the following is an equation for the line passing through the point -4, 1 that is parallel, so 4x minus 2y equals 3. So first off, it's giving me a line, right? It's giving me 4x minus 2y equals 3. Then it's asking me to find a new line that's parallel to that and has that point, right? So what I'm gonna do, first I'm gonna find this line's slope. Then I'm gonna use the point slope form or point slope equation to make a actual linear equation, right? So just bear with me. When you see a linear equation in standard form, which is 4x minus 2y equals 3. Whenever you see a linear equation in standard form like that, what you need to know is that the slope will always be -a over b. So if this is in format ax plus by equals c, then in this case, a is 4 and b is -2. So -a4 over b, which is -2. The negatives cancel out and it just ends up being 2, right? So the slope is 2. Does anybody have any questions about that slope formula or are we good? All right. So the slope is 2. Now we can use that with the point to find that point slope formula or the point slope equation, right? Y or the point slope formula is y minus y1 equals m over parentheses x minus x1. So now I can make a new formula, right? Y minus 1, which is the y, equals 2 times x plus 4. Right? X minus -4, whatever you want to say. Here, that's basically it, right? But now we actually have to simplify. So it's going to be y minus 1 equals 2x plus 8, right? Because we're distributing. Then we add 1. It's going to be y equals 2x plus 9. So here, that's going to be b, right? We didn't use decimals for this one. We could find a way to, but this kind of shows how at certain times, just being able to use algebra and know like point slope form, it's very useful because we were able to get that whole question without like using decimals at all, you know? So B is gonna be, or 2 is gonna be a bit harder now because it's actually using perpendicular, not parallel. So we're literally gonna use the same strategy, right? It's the same line here. So the same slope, right? The slope is equal to 2. We're gonna do the same, or no, the slope of this line is 2. Now, because it's perpendicular, we have to use the new formula, right? So the new line is gonna have a slope that is -1 over m or -1 over 2. So that's gonna be the new slope because that's just the formula, right? Now we can do y minus 1 equals -1/2 of x plus 4. Now y equals 1/2 x plus 4/2, which is 2, plus 1. So y equals 1/2 x plus 3. Oh. Must have done something wrong. Oh, negative. So it's -2, not +2. Minus 1/2 x minus 2. And then plus 1 still. So it's gonna be minus 1/2 x minus 1. Let me rewrite this because they got confusing. Alright, so y equals negative 1/2 x. Then that's negative 1/2 x, negative 1/2 times 4 is -2, so -2. Now I'm gonna add this 1 on both sides, because I did y equals. And that's plus 1. So y equals negative 1/2 x minus 1. Which is going to be option B. We can do this last one, number 3. Yeah. We have time. We have 4 minutes, should now. Yeah. This one is gonna be the same thing. We find the slope is parallel, so it's gonna have the same slope. That's gonna be -a/b or -3/4. Right? Now we just have to use point slope form. It shows you really how quick these questions can be. Y minus -3 equals -3/4 of x plus 2. Or x minus -2, but I'll just cut to the chase, right? So y plus 3 equals -3/4 x. And then that's -6/4. We can simplify that way. -6/4. Now I'm gonna do -3 on both sides. So y equals -3/4 x. Then I'm gonna simplify that to -3/2. So -3/2 minus 3. Then I'm gonna put 3 as 6/2 just to simplify that. That's gonna be y equal. Oh, wait. Yeah, that was a little bit of brain fart because this was the answer, yeah? Yeah, because the answer choices were already in point slope form, guys. So this literally right here will be the answer if we just did +3. So just by finding the slope -a/b, we literally have solved the answer because it's just y plus 3 equals then slope x plus 2. So here D will be the answer, yeah. Alright. That one you literally pretty easy. We just have to find that the slope is -a/b, so -3/4, and then plug in those points, right? So that is it for perpendicular and parallel lines, and it is 11:58, so. Yeah, midpoint and distance, we won't get to that today. I will be right back with volume, don't worry.
Alright. So I hope you guys found the tips interesting and nourishing, because I think that's what you need for this. Do you guys like this book, or do you guys like some of the stuff we were doing before? Like, what do you guys prefer?
Yeah, because we have been doing slides before. The other day we were just on Blue Book, literally doing the practice questions. do you guys think that maybe this is like, cause this definitely has more of a structure to it and it has like tips at the beginning that actually teach you the content. And then we get into the harder questions. So we just kind of wanted to know what you guys were thinking, you know? What you guys liked best.
The book, okay, this prep book, okay, awesome. Great book, okay, so we'll continue with this book then on Wednesday, we'll like and now from now on, like the rest of the lessons are very short, it's like one or two like tips per se. So we'll continue working on this and then I might post by the end of the week one of the full practice sets because this book has like 15 full practice sets for math. I'll upload that and then I'll upload the answer key so you guys can go ahead and like do some more independent practice.
Remember, it's there, you guys could use it, like, you guys could still be studying.
Yeah, so, yeah, alright, remember, again, Wednesday again, at 9 AM to 12 PM, through the same Zoom link, and then we'll be, doing office hours on Friday, so if you guys have any questions, guys can speak back, but other than that, we're good to go. Thank you guys so much for coming.
Hey, okay, we have a lot to discuss.
Are we done?
Yeah.
What are you gonna do?